Lesson 10, Operational Amplifier. Section 10.8. High-gain differential amplifier. This is a differential amplifier. And this is a current mirror. Let's combine these two circuits to implement a high-gain differential amplifier. This is a way to combine these two circuits. The resistors RL1 and RL2 are replaced with the current mirror. This forms a high-gain differential amplifier. TR5 can be represented by a current source, and TR6 can be represented by a diode. This part functions as a high-gain amplifier. Experiment 10.8. Construct this circuit. Adjust RCM so that VCM equals 1 volt. This sets IE equals 2 times 0.606 milliamps. Reconstruct this circuit as shown in this figure. This is to measure the voltage gain of the high-gain differential amplifier. Due to the current mirror formed by TR5 and TR6, IE1 and IE2 are approximately equal to 0.606 milliamps. The resistor RS2 is inserted to apply an input voltage in the order of microvolts. If the amplitude of Vs equals 500 millivolts, then that of VBG equals 500 microvolts. The reason for using this small input is that the voltage gain of this amplifier is very high. These are the results. The orange line represents the signal voltage Vs, and the purple line represents the output voltage VCG. The input voltage VBG is approximately 1/1000th of Vs. The voltage gain of the high-gain differential amplifier was 930. This is a high-gain differential amplifier. TR1 to TR4 are NPN-type transistors. TR5 and TR6 are PNP-type transistors. Let's replace NPN-type transistors, TR3 and TR4 with PNP-type ones, and then flip the circuit upside down. The circuit on the right-hand side is a PNP-type current mirror. We can do the same to TR1 and TR2, resulting in a PNP-type differential amplifier. Lastly, TR5 and TR6 are replaced with NPN-type transistors, and the current mirror is then flipped upside down to the bottom right. This forms an NPN-type current mirror. This is another high-gain differential amplifier. According to experiment 10.8, the voltage gain AV is approximately 1000. The voltage gain of the TL082 CP is 200,000. How can this high voltage gain be achieved? One of the answers is to connect a high-gain amplifier to the output of the high-gain differential amplifier. This is the same high-gain amplifier as the one in section 10.7. TR3 and TR9 form a current mirror, with TR9 functioning as a current source. The voltage gain of TR8 is roughly estimated to be 1000. Therefore, the total gain could be 1 million. A common collector amplifier is a choice for the level shifting. Section 10.9. High input resistance. This is a very high gain amplifier. The input and output voltages V1 and V2, and currents I1 and I2 of this amplifier are defined as shown in this figure. Let's focus on the input circuit. This is the equivalent circuit for TR1 and TR2. The input resistance of this differential amplifier Ri equals HIE1 plus HIE2, which is a few tens of kilo ohms. The input resistance of the TL082CP is 10 to the power of 12 ohms. This high input resistance is achieved by replacing the bipolar transistors TR1 and TR2 with junction FETs. This is the equivalent circuit for JFETs. I1 is very small, and the input resistance of this amplifier becomes 10 to the power of 12 ohms. The author of this material is Takeshi FURUHASHI, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.